അവിടെ എണ്ണ श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती शुक्लां ब्रह्मविचारसार परमा आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदां जाड्यान्धकारापहां हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्।
A very good afternoon to all. A very good afternoon to all the respected dignitaries, esteemed colleagues, and participants present here. This is Vidisha Bera, Assistant Professor of Computer Science and Technology Department, on behalf of Global Institute of Science and Technology, welcoming you all to our faculty development program on recent advances and future trends in AI and NLP. Before the initialization, a short brief about our college and department. Since establishment in 2007, our college, Global Institute of Science and Technology, Haldia, has been providing top-notch technical education and with vibrant academic and cultural atmosphere. It offers a range of multidisciplinary courses like diplomas in civil, electrical, mechanical, computer science and technology, information technology, and fire technology and safety engineering, affiliated by the University of West Bengal State Council of Technical and Vocational Education and Skill Development, as well as degrees in BCA and BSc IT with affiliation of MACAUT. GIST is recognized for its commitment to quality improvement and excellence in technical education. With a prestigious NBA accreditation in 2022, we, the Computer Science and Technology Department, emphasizes outcome-based learning tailored to meet the demands of modern industries and research-based academic fields. As the largest department of GIST, we are really glad to extend a heartfelt welcome to each of you to this online FDP today. In this era of rapid technological advancement, fields of AI and NLP are the most captivating and ever-evolving domains. As the two most demanding fields, AI and NLP are revolutionizing the way we interact with machines and the world around us. From virtual assistants to language translation, sentiment analysis to personalized recommendations, the applications of AI and NLP are vast and profound, touching nearly every aspect of our daily lives. Through this FDP, we will learn the latest developments in AI and NLP, offering insights into cutting-edge research, practical applications, and emerging trends that are shaping the future of these disciplines. Our distinguished speakers and experts will share their knowledge, experiences, and perspectives, providing you with valuable insights and tools to navigate this dynamic field. I encourage each of you to actively engage in all the sessions, ask questions, and participate in discussions to make the most out of this great opportunity. Once again, I welcome you all in this online FTP and look forward to an enriching and insightful journey ahead. Now, I would like to request our respected Principal Sir, Dr. Bikramjit Chaudhary, to share his valuable elocution with us. So, sir, over to you. Over to you, sir.
Yeah, thank you, Vidisha.
Yeah, thank you.
Uh, am I audible?
Yes, sir.
Yeah. So, good afternoon to everyone who have gathered here. I welcome you all to today's the faculty development program focused on the artificial intelligence and natural language processing. That is a 5 days faculty development program organized by my college, that is the Global Institute of Science and Technology, Haldia. It is essential for us, the educators, to stay ahead of all the new advancement and skill necessary for revolutioning the various industries and opening up the new possibilities for the future. In the future, you can find out the AI is the most important area which are basically we are looking for. The AI and NLP, or you can say the machine learning, these two words comes up daily conversation. But these two words represents the powerful tools to improve how we teach and engage with our running and changing society. AI has made many breakthroughs in the recent days. Apps like ChatGPTs are only possible because of the NLP. Furthermore, in the future, the intelligent machines will coexist in harmony with humanity and enhancing our lives in ways we never thought were possible. We can shape a future with AI and NLP empowering us to tackle challenge and unlock the new opportunities for innovation and growth. In future, if we think about the AI is everywhere. We can find out in our mobile system, we can find out in our day-to-day used product, in in our machine, in our each and every activity, we depend upon the AI. There is some positive areas and negative areas also. If we use the AI for the benefit of our development, of our social, of our, you can say for the betterment of the mankind, so that is only possible with the AI, with the human and AI both together, we can face the challenges, tackle the challenges, and unlock the new opportunities and innovation for the future growth. We organize the faculty development program on the topic of AI. This session will provide us the fundamentals of AI and NLP. Whether you are an expert or not, there is something for everyone who may be the expert or who may be the newcomer in that particular field. This particular session we conduct, there is something for everyone because there are lots of experts are coming from the different organization, different reputed organization. They share their views, their knowledges with us, and we can get something from them. And we expose our future. We maybe increase our knowledges. We increase our education areas. I hope this session will give us a new perspective on AI and NLP. Hopefully, we can open our mind to welcome the new ideas, concept that can help for the betterment of our new world and also enhance the educational experience for us and our students. The first thing I could rather say that without mathematics, the knowledge of the mathematics, you could not understand the AI. So that's why there are some renowned speakers are from the mathematics background. They are in that particular faculty development program. In the mathematics, calculus, differentiation, integration, linear algebra, probability, these are the things you should know about for understanding the AI. Some other topic we can say the data types, if else, for loop, function, oops, in the Python field, it should you should know about that particular language, that most probably you should understand that thing better way. And the next thing, that is the data analytics and the frameworks. These two things are the most important thing you should understand properly to know proper AI and the machine learning. There are lots of scope for the AI engineers in future. You can find out in the BTech area, or maybe some graduation course are available in the market. It's in the earlier days, that is the computer science is the only thing. But nowadays, the BTech in artificial intelligence, machine learning, these are all available as per the approval of the AICTE and all these curriculums and the recognized by the UGC also. So these are the main thing the students is looking for right now, because the high paid salaries are basically in that particular area nowadays is the most important. In India, there is a lots of scopes in AI. Sometimes we can find out in the AI that is the some other countries, not in India, but the other countries are famous for the AI development. But now my country, that is India, is not lagging behind. There are top AI-based companies are available in India. You can find out the Boss, Oracle Finance Solutions or Services, the Persistent System, L&T Technology, Tata Elxsi, Zen Technology, Happiest Mind, FL India, Kelton Technologies. These are the companies are in the Indian market. They are creating their best. They are doing their best in the future and create a good footprint in the world market. In that particular faculty development program, you can find out our honorable speakers are Professor Samarjit Kaur, Professor of National Institute of Technology in the Department of Mathematics, Dr. M. Tanveer, Associate Professor of Indian Institute of Technology, Indore, Department of Mathematics, Professor Bishwapati Jana, Professor and HOD of Vidyasagar University, Department of Computer Science, Professor Chandan Chakraborty, Professor of NITTR, Kolkata, Department of Computer Science and Engineering, Dr. Sudeep Kumar Noskar, Associate Professor in Jadavpur University, Department of Computer Science and Engineering, Dr. Bhaskar Mandal, Assistant Professor of National Institute of Technology, Patna, Department of CSE, Professor Som Subhro Gupta, Professor and Dean of Swami Vivekananda University, Department of Science, and Dr. Shantanu Modak, the Associate Professor of Bengal Engineering College and Technology, Department of IT. I welcome on behalf of GIST all the speakers, and I hope that with your knowledge or with your sharing views, all the registered candidate for the faculty development program, they become beneficial. So today's speaker, Dr. Sudeep Kumar Noskar, Associate Professor in Jadavpur University, Department of Computer Science and Technology. I welcome you, sir, for the first honorable speaker in our faculty development program. I hope everybody should get at least something from this faculty development program, because there are lots of registered candidates are available here, and make it become a great success. So thank you so much. Thank you everybody. Thank you the coordinator and the Department of Computer Science and Technology of my institute, all the faculty members, though they are basically organizing that particular event, and hopefully it become a grand success. Thank you so much. Over to you, Bidesha.
Yes, sir. Thank you very much, sir. Thank you, sir, for sharing your valuable thoughts with us. With your thoughts and views, we will proceed to our core part of today's FDP. So now, before inviting today's speaker, Dr. Sudeep Kumar Noskar, I would like to share his achievements and contributions. So, Dr. Sudeep Kumar Noskar He's an associate professor in the Department of Computer Science and Engineering at Jadavpur University, Kolkata, India. He received his UG, PG, and PhD degrees from Jadavpur University. He was a postdoctoral researcher at National Center for Language Technology, School of Computing, Dublin City University, Ireland, for over 4 years. Earlier, he briefly served as an assistant professor, computer and system sciences at Vishwabharati University, Shantiniketan, India, and as a lecturer in the Information Technology Department at Bengal Engineering and Science University, presently IIEST, Shivpur, India. He received Young Faculty Research Fellowship Award for the tenure of 2016 to 2021 under the Visheshwara PhD scheme for electronics and IT from the Digital India Corporation of the Ministry of Electronics and Information Technology, Government of India. He is an associate editor of Sadhana Academy Proceedings in Engineering Sciences, an SCIE journal of the Indian Academy of Sciences, published by Springer. His research interests include natural language processing, speech processing, computational linguistics, and related areas. Today, he will deliver his talk and expertise on natural language processing, a broad perspective. Now, I would request Dr. Sudip Kumar Noskos sir to deliver a profound talk on natural language processing. So, I'm sure we will definitely learn and enrich ourselves with his expertise and knowledge today. For a few seconds, he will join us. So I will request all the participants to keep patience. He will come in shortly. Give us 2 minutes for his joining. Please keep patience. I would request all the participants, please stay with us for 5 minutes. Our speaker, Dr. Sudip Kumar Noskar sir, will join shortly. Please be with us. and keep patience, please. All the participants and dignitaries here, please keep patience for a while. Our speaker, Dr. Sudeep Kumar Nashkar, will join shortly. Welcoming you all again to the Faculty Development Program on behalf of Global Institute of Science and Technology. All are all present here, all the participants and dignitaries, welcoming you all again. Our speaker, Dr. Shudip Kumar Noshkar sir, has has joined us shortly. So once again, I'm going to introduce Dr. Shudip Kumar Noshkar sir. Sir, are you here, sir?
Yes, Sam.
Okay, sir. Sir, Dr. Shudip Kumar Noshkar sir is an associate professor in the Department of Computer Science and Engineering at Jadavpur University, Kolkata. He received his UG, PG, and PhD degrees from Jadavpur University. He was a postdoctoral researcher at National Center for Language Technology, School of Computing, Dublin City University, Ireland, for over 4 years. Earlier, he briefly served as an assistant professor, computer and system sciences at Vishwabharati University, Shantiniketan, India, and as a lecturer in the Information Technology Department at Bengal Engineering and Science University, presently IIEST, Shivpur, India. He received Young Faculty Research Fellowship Award for the tenure of 2016 to 2021 under the Vishwaswara PhD scheme for electronics and IT from the Digital India Corporation of the Ministry of Electronics and Information Technology, Government of India. He is an associate editor of Sadhana Academy Proceedings in Engineering Sciences, an SCIE journal of the Indian Academy of Sciences, published by Springer. His research interests include natural language processing, speech processing, computational linguistics, and related areas. Today, he will deliver his talk on natural language processing, a broad perspective. So, now I would request Dr. Shudip Kumar Nosko sir to deliver a profound talk on natural language processing. So, I am sure we will definitely learn and enrich ourselves with his expertise and knowledge today. So over to you, sir.
Okay. Thank you very much for the nice introduction, and good afternoon to all of you. So I guess today's is the first lecture of the FDP or short-term course. I don't know whatever it is.
So this is the first session. Yes, sir. Thank you, sir.
Yeah. So I thought it might be better. It would have been better to start with an AI lecture, but nonetheless, NLP is one of the biggest areas of application of AI and machine learning. So it will be no harm to start with NLP. I'm sure you will have many other sessions, following sessions on AI and machine learning in general. Okay. So let me share my screen. Is it visible?
Yes, sir.
Yes,
Okay.
sir.
Maybe I will switch on my camera just in case the video comes better. Okay, so welcome to this lecture on natural language processing. So in this lecture, our objective is to basically learn a broad overview about what natural language processing is, why it is important, and what are the different tasks and applications of natural language processing. So it will mainly focus about what are the different tasks and why do we need NLP and what are the different applications and so on, but not so much on how we do it. Okay, so it will be mainly about what is NLP. So hopefully after this lecture, you will get a very broad overview about many different topics. So you will, because if you are totally new to NLP, you don't know about many of the terminologies and the applications and the terms and the core tasks in natural language processing. But after this lecture, hopefully you will learn a lot about NLP, what are those tasks and applications and intermediate tasks. Okay. So what is natural language processing? Natural language processing is nothing but processing of natural language, as the name suggests. So you'll have to build computer systems that are able to process natural language content. Okay, now um, why NLP is difficult? Because I hope many of you, in fact, most of you are from computer science. So if you are from computer science, you know about compilers, and there you know about how to process programming languages. So how natural language processing is different from compilers? The answer is you here you will have to deal with natural languages. So if the question is, what is a natural language? Natural languages are those which are spoken by humans for our telecommunication purpose. I mean, if you think of C, Java, those are also languages, but those are programming languages, they're not natural languages. We do not speak in C or Java. Okay. Now, the thing with natural language is that if the question is why NLP is so difficult, I mean, if NLP was not difficult, then it would have been sufficient to just make a compiler for every natural language, like for example, Bengali, Hindi, or English. That would have done our job, that would have solved the purpose. Okay, but that is not the case. In fact, you'll soon see how difficult NLP is, because the thing is, natural languages are extremely ambiguous, and it is extremely difficult to process natural language contents. Okay. So just like in compilers, you have lexical analysis, syntactic analysis, and semantic analysis. These three layers. Also here, because you are dealing with languages, you will also have to deal with this what we call lexical analysis in compiler is basically equivalent to morphological analysis in natural language processing. Then comes syntactic analysis, just like in compilers. Then comes semantic analysis, and then above all, we go to pragmatics or discourse. So we'll touch upon all of these layers and the different tasks in these layers. So in all these layers, you'll have to face with different types of ambiguity. And here I will present some. I will start with some ambiguities that you'll have to face when dealing with natural languages. Okay, so basically the challenge is why NLP is difficult. Say, for example, if you take the example dryer, this English word dryer, you know that dryer could mean the machine which dries, an electrical machine, or it could mean the adjective more dry, right? Similarly, I hope most of you are Bengali, because I have some examples in Bengali here. So, say, for example, take this word chini, you know that chini can be sugar or chini can be, I know him, Amitake chini, okay? Similarly, chuti means to whether it refers to the verb run or whether it refers to the noun holiday. Okay. Similarly, words can belong to multiple part of speech. You know that words can belong to 7 part of speech: noun, pronoun, adjective, verb, and so on. In fact, if you think of the word round in English, this word can belong to 5 part of speech among 7 part of speech. It can be a noun, it can be a verb, it can be a preposition, it can be an adverb, it can be I think, noun, verb, adjective, adverb, and preposition. Okay. Similarly, the word, even if the word belongs to a particular part of speech, say, for example, the word bank, take only the noun meaning of bank, even it could refer to the river bank or the financial bank. Similarly, later, an element of the alphabet or written missive. Okay. Now, how do we disambiguate in natural language processing when dealing with these ambiguities in text? We always look at the context. Context is all you have. So whatever disambiguation you will have to make, you will have to make it based on the context. Take for the example, well, first of all, the word ball refers to the physical object ball, like a football or cricket ball, or it could refer to a ball dance. Okay. Now let us consider only these two meanings of the ball. Okay. So now take the example, John kicked a ball. Now here in this example, you know that kick is a transitive verb which requires a physical object. Okay, so the FrameNet says that kick requires a physical object. So here the ball has to be a football or cricket ball, something. Okay, a physical object, a round-shaped ball. The ball lasted until midnight. Here the verb last, according to the FrameNet, it requires an event as the subject. Okay, so in this case, it could not be a physical ball. So here it is the ball dance. But take the third sentence, when you hold a ball, now can you disambiguate the meaning of ball from this sentence? The answer is no, because you have the verb hold, which is also ambiguous because you can hold something physically, you can hold a pen, you can hold a ball, okay? Or hold can also mean to organize. You can hold a conference, you can hold an FDP or something else, okay? You can hold a ball dance or a party. So here you need further context because this context is not good enough to resolve the ambiguity of both the verb hold and the ball. Similarly, structural ambiguity appears. Okay, first of all, the purpose of syntactic analysis or structural analysis is to basically assign a parse tree to a natural language utterance or a sentence. Just like in compiler, you produce the parse tree of a statement. Here, the purpose of syntactic analysis is to basically given a sentence in a particular language and the grammar of that language, you'll have to produce the parse tree. Okay. Now, you can have many sentences where it can be extremely ambiguous to produce the parts tree for the particular sentence. In the first sentence, flying planes can be dangerous. In this particular sentence, you know that here it means basically, well, first of all, it is an ambiguous sentence. In this case, you can assign two perfectly valid parts trees for this sentence. So here it could either mean the act of flying planes can be dangerous, okay, or it could mean the planes that are flying, they can be dangerous. Now, depending on the interpretation of the sentence, you will have two completely different parts, okay. Similarly, take the second example, visiting relatives can be boring. Here visiting could be the subject. It could mean that I don't like to visit relatives places, okay, or it could mean that relatives who visits your places, you find them boring, okay. In that case, relatives would be the subject of this sentence, okay. Take the following two sentences, time flies like an arrow and fruit flies like banana. Although they look very similar on the surface, in the first sentence, you know that time is the subject, flies is the verb, and like an arrow is a prepositional phrase. So in English, we call a prepositional phrase, any phrase that starts with a preposition is called a prepositional phrase. They basically act as a modifier. They are either modified a noun phrase or the verb, okay? So, but in the second sentence, fruit flies like banana. In this sentence, like is the main verb. Okay, like is not a preposition here. Like is the main verb, and fruit flies. This whole thing is the noun phrase or the subject of the sentence. Okay, so although the sentence look very similar on the surface, they have very different parts trees. Now, the boy saw the girl with telescope. Do you see an ambiguity in this sentence? Well, there are some ambiguities in this sentence, in particularly with the prepositional phrases in English. Where to attach the prepositional phrase is a very complex problem. So, because like I said, a prepositional phrase is a phrase that starts with a preposition. Okay. Now they always modify something. So here the question is, with a telescope is a prepositional phrase. Now, whether it modifies the boy or the girl, the question is, if you produce a parts tree, where you attach with a telescope to the boy, okay, then that sentence basically means that the boy had the telescope. If you attach with the telescope with the girl, then it means that the girl had the telescope. Or it could also, you can have a parts tree where you attach with the telescope with the verb saw. Maybe it does not matter who had the telescope. Maybe the telescope was in the garden or in the park, because in the mountains, in the viewing points, you have those telescopes. Maybe so it does not matter who had the telescope. Maybe the act of seeing was done with telescope. Okay, that is what the sentence means. In that case, you will attach the with the telescope prepositional phrase with the verb saw. Semantic ambiguity. Well, the semantics basically deals with meanings of words. The Latin word same basically means meaning. Okay. Now, when a word can have multiple meanings, that word is said to be a polysemous words. Polyseme. Okay, multiple meanings. So if you look at these two different sentences, in both these two sentences, you have the word bank and interest, but appearing in completely different sense. Okay. In the first one, both bank and interest appears in the financial sense, financial bank and financial interest rate. But in the second one, it refers to the river bank of the Mississippi River, and it refers to the general interest, not the financial interest. Okay. Now, multi-word expressions are those which are made up of consecutive tokens or words, because typically when doing parsing or some other task, we typically consider a word as a token. Okay, but when you will have instances of natural language sentences where multiple words make up a single, like a token. They act like a single token. Take, for example, the first one, John eats in on Sundays. Here, eats in is a phrasal verb, okay, which has the meaning that eating at home, okay. But although the second sentence starts with the exact same sequence, John eats in, here in is a preposition, okay. Similarly, for the following two sentences, in both the sentences, fall 4 appears, which is a multi-word expression or multi-word unit, but it has two different senses. In the first one, it basically means that John fell in love with Mary, whereas in the second sentence, it means that John was deceived, because fall for has this meaning to be deceived. Okay. Another very complex phenomena in natural language is how to deal with idioms, because idioms are made up of consecutive words, a sequence of words. But the problem with idioms is that the meaning of the idioms are cannot be made up from the meaning of the component words. For example, kick the bucket means to die. Now, dying has nothing to do with kick or the bucket. Okay, so where does the meaning of kick the bucket? I mean, the meaning of dying comes from. Okay. Similarly, let your hair down means to relax. So, how do you discover the meanings of such idioms and how do you translate them? Co-references also is an very complex and difficult task in natural language. Co-reference basically means both co-reference resolution and anaphora resolution. In fact, I should have written here anaphora resolution. In languages, pronouns, you know that pronouns do not have any existence of their own. For example, when you say see, it, they, all these words, they refer to something, okay, because they do not have any existence of their own. Now, the task of anaphora resolution is to basically link which exact word or phrase a particular pronoun is referring to. Okay. Similarly, co-reference basically means, so you can call the same thing by multiple names. Say, for example, you can call say, for example, take the example of Prime Minister of India. You can call him Mr. Modi, Narendra Modi, Prime Minister of India, the Prime Minister. Okay, all of them refer to the same thing. So all of them refer, they are just said to be called co-references. Okay. So here let us deal with the anaphora. So you can see the two sentences here. In the first one, them refers to some of the people. Okay, some of the people in the crowd. Whereas in the second sentence, them refers to some of the fire or some of the bullets. Okay. Now, one more aspect of anaphora resolution, the difficulty of anaphora resolution is that most of the times, the thing that an anaphora refers to is not present in the same sentence. It might be in the previous sentence or maybe the sentence before the previous sentence. Okay. So this is like a cross sentence linking task. Take, for example, I mean, if you are dealing with dialogues, if you want to build a sophisticated dialogue system, like a chatbot, then you'll, I mean, and you will have to deal with anaphora, because why do we use anaphoras or pronouns? To not make the produced content not repetitive. Otherwise, it will sound very repetitive and boring. Okay, if you mention the same name many times throughout the text. Take, for example, this case of chatbot. Say the user says, my sister has a friend called John. Then the agent or the chatbot, it says, really, tell me more about him. Then the user says, she thinks he is so funny. Okay. Now here the chatbot has to infer that she here is referring to the sister of the user. He is referring to John, who is the friend of the sister of the user. So at every stage, the chatbot has to make these links or connections. Otherwise, it will not be able to make. I mean, it will not be able to make sense of the what the user is saying. Okay. There is something called Winograd Schema Challenge. So it is named after Professor Winograd from Stanford University, who was the PhD supervisor of Sergey Brin, you know, who was a founder of Google. I mean, he did not finish his PhD, but that's not the matter. So Professor Winograd said that, yeah, I mean, this anaphora resolution task is in fact so difficult that it is in fact more difficult than Turing test itself. He suggested this. Okay. Now the Winograd schema is something different from simple anaphora resolution. So Winograd schema is, look at this sentence: the city councilman refused the demonstrators' permit because they feared violence or advocated violence. So you'll be given a sentence in which you will only change one word, and because of that, the pronoun in the sentence will refer to something else. Okay. And this thing is called the winograd schema, and this is still now, this is open challenge. Until 2 years ago, the accuracy achieved over this, you might think this is a quite simple task, but this is a grand challenge. There is a price of $25,000 US dollar, and I think still, I mean, if you are able to have 90% accuracy for solving this task, then you will be doing this price. So you can now imagine how difficult is the task. So here in this particular case, if the sentence was that they feared violence, then they would refer to the city councilman. But if the sentence was they advocated violence, then they would refer to the demonstrators. Okay, so you can see how the pronoun is referring to something else because of just one word change. Here are some more examples of ambiguity. He noticed the shaking hands. Do you any ambiguity in this? Well, it could mean that I noticed her shaking hands with someone else, maybe with her friends or someone. Okay, or it might mean that he noticed her shivering hands. Maybe her hands were shivering because of tension or because of cold or whatever. Okay. I like tennis. Do you see any ambiguity in this? Well, the English word like is extremely ambiguous in English because the thing is, there is a thing called ellipsis in natural language processing. So we tend to drop words sometimes from text. Okay, so this phenomenon is called ellipsis. Take for example this sentence: the movie I watched. Uh, Hold on a second. The movie I watched last night was great. Okay. So in this sentence should have been the movie that I watched last night is great. In that case, the parsing would be much more. If you drop the word that, then parsing would be much more difficult. But we have this tendency of dropping words. Okay, and this phenomenon is called ellipsis. Now here in this case, I like tennis. What do I like about tennis? Do I like to play tennis? Do I like to watch tennis? That thing is not mentioned in the text. Okay, so because of the phenomenon of ellipsis, because we often assume that if I say I like movies, I like it means that I like to watch movies. If I say I like rock music, it perhaps means that I like to listen to rock music. Okay, so we always assume that the hearer or the listener, he or she will be able to understand what we are saying. Okay, but that is not the case with machines. Machines are not as intelligent as we are. So how do you deal with this? In fact, if you think of the case, so take this example. I like tennis. I like rock music. I like fish finger. I like rasgullas. I like whatever. I like decor music. I like. I'm saying everything I like. You know, if the question is what food do I like, the answer should have been a fish finger. So how do you know that I like to eat fish fingers? Okay, so that is the question. So you'll have to resolve the ellipsis before the verb like. Okay. Now, if you take the following two sentences, John is eager to please and John is easy to please. They look very similar on the surface, but in the first sentence, John is the subject. John is eager to please people, but in the second sentence, John is the object. It is easy to please John. Okay. So although the sentence looks very similar, their parts will be very, very different. The chicken is ready to eat. Do you see any ambiguity in this? Well, the ambiguity is, I mean, this is a native expression that is said in, say, for example, in British English or in American English, wherever English is the mother tongue, I mean, the native language, okay? The chicken dish is ready. It basically means that. But you know that chicken is an animal and it can also get hungry and it also has dinner. So maybe the chicken is ready for its dinner or something, okay? So how do you know which interpretation should you give to this particular sentence? Now, ambiguity is pervasive. Look at the sentence, I made her duck. Now, if the question is how many sentence or how many meanings you can think of for this particular sentence, you can perhaps think of 2 or 3 meanings. But in fact, this sentence can have at least 5 different senses. So it could mean I cooked a duck dish for her. Okay. It could mean I cooked a duck dish. I mean, basically, it means that she had a duck, and I killed the duck, and then I made a dish out of it. Okay. The second meaning is that. The third meaning is like I created a maybe a plaster duck or maybe a origami duck, paper duck, and give it to her. Okay. The fourth meaning is quite obvious. This duck mean to lower one's head. Maybe I threw something at her and she lowered her head. So that's the meaning of duck. Or maybe it could mean that I am a magician and I waved my magic wand and turned her into a duck. Okay. So how do you know what exact interpretation to give for this particular sentence? Okay. In fact, I will give you an example that. So I hope you can see my screen here. The very term NLP is ambiguous. Do you see any ambiguity in this term, natural language processing? When you heard the term natural language processing for the first time, you knew that must be talking about processing of natural language, right? So the meaning that it make up is basically means processing of natural language. Okay, but it could also mean perhaps language processing which is natural. Okay, take this particular sentence. Okay. Okay, in this particular sentence, the natural language processing should be parsed as humans' language processing capabilities, which is natural. Okay, so not as natural language processing, the meaning that we have been referring to so far. Okay, but this is a problem with humans. Like we humans are so intelligent that we do not even look at the ambiguities. The meaning is always clear to us. Okay, but once you start studying the natural language or working on natural language processing, you will start to see the ambiguities in natural language that the computer sees. Okay, so in fact, if you think of uh, I mean, so natural language processing also, by the way, natural language processing is also referred to as computational linguistics, okay. In fact, computational linguistics and natural language processing, they are nothing different. In fact, the highest impact factor journal in our line of research is named after this, which is an ACM journal, ACM transaction. So it is called computational linguistics. And but the thing is, computational linguistics is also taught in linguistics department, typically in the humanities department. It is taught as a application, like an applied subject, but they do not teach so much about the algorithms and so on. They mainly teach about the different computational different linguistics approach that are required for computational analysis of text, okay, or natural language. But the thing is, language processing is considered to be a cognitive task, so cognitive science. So how the question is, how do we process language? How do we, as humans, process language? So it should be answered by cognitive scientists. Okay, but cognitive science does not give us a very good idea about how we humans process natural language. In fact, if you think of a person who has never gone to school, he or she, although cannot read ABCD or the alphabet of that particular language, he or she still can make perfect sense of, the conversation, or he or she can perfectly communicate in his or her mother tongue. Okay, so how does he or she do that? So he does not know anything about the grammar. So how does he do that? Okay, so that is a challenge. So the thing is, cognitive science does not give us a very definitive idea about how we humans process natural language. If that was the case, then we could have mimicked that process, and maybe natural language processing could have been somewhat simpler. Okay. Now, speech processing is also considered a language processing task because speech and text, these are just two different modalities of text. They are nothing else. When I'm talking to you and giving this lecture, so my vocal cord is producing a signal, which is a speech, which encodes some linguistic content, and then it reaches your ear through this internet. and your brain makes sense of it. Okay, your brain decodes the speech signal and then decodes what is being said. Okay, so think of this case. I mean, so in speech, we'll say, I mean, we'll come to speech processing. What are the tasks in speech processing? But one of the main tasks in speech processing is to basically called automatic speech recognition. So given a speech signal, you have to transcribe the text. You'll have to write the text in maybe in a text file or something like that. Okay. So think of developing an ASR system that can handle with this transcribing this simple utterance I made attack. Now, if you look at the some of the sentences in the left, you will find that all these sentences sound very similar to this original one I made attack. Okay. In fact, if you look at these two ones, I mean the ones in the green, then you will find no distinction whatsoever in the pronunciation than with the original sentence. Okay, now how does an ASR know that this sentence or this sentence does not make much sense? So this is the intended text. Okay, now there is something called language models in natural language processing. So either n-gram based model, or these days we have neural network based model, language models. And just using a language model would say that this sentence is much more likely than this all the sentences. All the sentences will have very low probabilities according to the language model. Now there is a thing called cross version problems. I will not explain it, but just for example, so these are basically sentences taken from uh, 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 newspapers. Basically, I think all of them are taken from Wall Street Journal. Okay. So in fact, you will notice that sometimes because these newspaper headlines, they tend to be very short, they tend to drop some words and they tend to be cryptic. Okay. In fact, sometimes they write the news title in such a way that it will be difficult for you to discover the actual meaning of the title without reading the news items. Okay. So take for example the second sentence, this one: teacher strikes advocates. What is the meaning of this? No, I'm 100% sure that the first meaning that comes to your mind is not the intended meaning. Okay, the teacher is striking the kids' future idol. That cannot be the news headline. Okay, so here the news is about a teacher strike. Okay, so because of the teacher strike, there are no classes being held, and so kids are being idle. Okay, so that's the intended meaning. Teacher strike is making the kids idle. Okay. So now we can see how difficult it is to process, particularly the news headlines. In fact, I remember some time ago, in fact, before the lockdown, I think I um, I there was a news headline in the front page of Andhrajan News. If you are Bengali, you know Andhrajan News, Andhrajan Potrika, Lok Sabhay Nirav Modi. Okay, so this was the news headline. Now you know that there is some person who is near Modi, who is absconding. Okay, so it could mean that that person is present in the Lok Sabha, but that news was about Modi being present in the Lok Sabha, but silent, no speech at all, or not even a single talk in that particular day. Okay, so that is the intended. So this is a problem. So in fact, the meaning that is apparent to you, that looks very probable to you, is not the intended meaning. Here are some more examples of ambiguity. In this particular sentence, you have every word. So in English or in syntactic processing, not in English, for every language, in syntactic analysis, you have a task called POS tagging. Again, I will give examples to this. So where the task is to basically assign a POS tag to every word in the sentence. Okay. So POS tagging is in fact said to be the first task in parsing. So once you are able to assign the correct POS tags to every word in the sequence, the parsing becomes easier. Okay. So if you consider this particular sentence, oil prices rose, gas prices rose up. Here in this particular sentence, every word belongs to at least two part of speech. Okay. Now, can you think of, do you think this is a valid sentence? Does it have any meaning at all? Is ship shipping ships shipping ships? Okay, first of all, you know that ship means ram or bheda, and then ship means jahaj. But here, the entire sentence, first of all, this is a valid sentence, and this entire sentence is made up of the jahaj sense of ship. Okay, but again, ship, ship can also mean to ship, to as a verb, to ship something. So here, if you look at this picture, then the meaning will become clear. So these vessels, these are shipping ships. Okay, these are shipping ships because they are also carrying ships, and the larger vessel is a ship shipping ship. Okay, so this is the ship shipping ships. It is shipping. These are shipping ships. Okay. Uh, Again, a very complicated sentence. You might think this is an invalid sentence, but if you think of this will, and will, the four will with a capital W as four different persons, then you will be able to make sense of it. This entire sentence is made up of will as a person name, okay, four different persons, then will auxiliary verb. Will basically means the act of writing a will, okay, and will means the decree, the noun will. So this sentence is a valid sentence. Similarly, this is another classic example of ambiguity in English. So this entire is made up of three different senses. Buffalo is a state in US in which there is New York City. Then buffalo also means to, buffalo is an ox or bull. And then buffalo also means as a verb to bully someone. Okay, so this entire sentence is made up of all these things. In fact, there is an ellipsis here. So here it should have been that, but even without the that, the meaning is clear. Okay. So you can think of the difficulty of the problem. You are as a human. First of all, humans does not require grammar or even school knowledge, school education, or even college education, or forget about linguistics to make sense of a particular sentence in his or her mother tongue. Now you are an educated person, a highly educated person. You are having difficulty to process this particular sentence. Now, how can you expect a computer, which is a dumb system, which does not have zero, does not have any intelligence, how can we make it more intelligent to so that it can become able to process such sentences? Okay, so now we can understand the difficulty of the task. Now, like I said, we context is all you have, and all the disambiguation that you will have to make is has to be made based on the context. Now, I do not watch TV, so I mean, for news, I only look at Google News when I have time. So I scroll through Google News. So one day I was watching this Google News in my mobile phone, and I found this in this Mehbooba Mufti wants JNK students arrested for celebrating dot dot dot. Now, when I read this part of the sentence, I immediately thought this is not what I know. I think you might know about this incident. So Pakistan won in World Cup, beating India, by, I think by 10 wickets or something like that. And some students were celebrating that, and because of that they were arrested, and which was an unfortunate event. But anyways, so this is not what it suggests. Okay, then I went to the news and I found that the news is actually this, and because in the news headlines it often crops the, because sometimes the news headline is very long, so it crops the last part. So the actual news headlines is this. Now, once I saw this, I could make sense. Yeah, I thought like, yeah, this is what I know. Okay. Now, this is not about that case, but think about this particular sentence. If you did not have the word released, now look at this sentence. So these sentence basically mean that Mehbooba Mufti wants those students to be arrested, right? But if you had the released at the end, then the meaning of the sentence reverses 360 degree, almost to the, exactly opposite. Then it basically means that Mehbooba Mufti wants the arrested students to be released. Okay, so just because of this one word present or absent, the meaning of the sentence reverses 180 degree. Okay. Um, how, in fact, if you think of how, when I started doing NLP some 15 years ago, 15, 20 years ago, so then NLP was not this difficult. We did not have all these tasks that we have these days. But there, the book on NLP started with this example of how ambiguous is and. So because you know that and is a conjunction, it conjuncts two things. Okay, now those two things you will have to discover from the text. Okay, so the task is to basically given a sentence in which the word and appears, you'll have to find what the particular appear, what this and connects, okay, the two entities. Now the thing is, and can connect almost anything. So and can connect to nouns, like for example, principal and teachers, colleges and universities. It can connect to pronouns. It can connect to adjectives, young and vibrant democracy. It can connect to verb, like singing and dancing. It can in fact connect to auxiliary verbs. I can and will do. Okay. Similarly, it can connect to adverbs. In fact, anything. It can connect to prepositions. It can connect to noun phrases, verb phrases, to clauses, to sentences, anything. So here the task is to basically identifying the boundaries of this. So for example, you'll have to say that um, to the left it connects in, okay, not lines in or not computer lines in, just in, and to the right it connects around. Okay, this is the task. There are also some other tasks in natural language processing, because these days with the rise of the social media text, you have so much of noisy text in the social media. So your natural language, your natural language processing solution should be able to process those noisy user generated content. Those are typically called UGC, user generated content. So you'll have to, your system should be able to understand that this so basically refers to the word SO, okay? Because you don't have any word in English which is called SOO. This U refers to the English word YUU. These two is in fact not the number two. These two here refers to the English preposition to, TO2, okay? So now we can see the complexity of the problem. And in fact, in social media, sometimes people write this intentionally. Maybe the user wrote this intentionally to give emphasis on the word so. Okay, maybe you'll find sometimes great with a lot of T's. Okay, so this is the called the task of text normalization. I will come to this. Now, in fact, so we make this hypothesis that if you see a hyphen in natural language text, then you make the sense that this, the word to the left of the hyphen and the right of the hyphen, they are joined. Okay, are they act as a single token. These two tokens. Okay, so if you make that hypothesis for this particular sentence, then you will make a wrong hypothesis, because in this particular case, the hyphen is between New York and New Haven. Okay, so there is a railroad between New York and New Haven, and this hyphen is connecting this entire New York token with New Haven token. Okay, so how do you know that? Then I have already discussed about idioms. Neologisms. So there is a thing called coining new words in language. So in fact, every language is growing. They are coining new words from other languages, foreign languages, and in fact some making up some totally new words. In fact, if you think of on the word unfriend, you did not have this word until Facebook came into being. You did not have the word retweet until Twitter came into being. Similarly, words like romance. So perhaps you can the first time you heard that word unfriend, you perhaps could make sense of that word. Okay, but how a computer can make sense of a new word that it has not never heard about, it has never seen in the training data, how it is supposed to discover the meaning of such words? Okay. Then another aspect of natural language processing is that sometimes you need world knowledge, not just linguistic knowledge. Because if you think of the these two sentences, Mary and Sue were sisters. So we have this world knowledge that sister is a relation. I mean, if A is a sister of B, then B. I mean, if A and B are sisters, then A is a sister of B and B is a sister of A. But if you say Mary and Sue are mothers, it is not that kind of a relation. It is a directional relation. So it is not that Mary is the mother of Sue or Sue is the mother of Mary. Okay. It simply means that both Mary and Sue are mothers. Okay. So we have this world knowledge, but the computer does not have world knowledge. So solving some problems require having some world knowledge. I will give examples where we need this. Then another task in natural language processing is called named entity recognition or entity recognition. So named entities are those in English. Named entities are basically proper names. Okay, so take for example personal names like your name, organization name, place name. These are all named entities, and they carry a lot of information. That is why identifying named entities is very important. In fact, I just today while I was watching the Google News, I found a funny news that there is a, I'll tell you, I think I have, yeah. So I should have included in the slide, but I did not have the time. Anyways, so the news is about Hatia and Ernakulam railways. Okay, so there is a, I mean, on the trains, you know that the a yellow signboard saying the source station and the destination station, and Hatia has been wrongly translated to something in Malayalam, which I cannot read, but it basically says the meaning of that sentence is murderer. Okay, because Hatia and the word Hatia is very close to Hutta. So I mean, so the thing is, I mean, those names, you know that proper names should not be translated. First of all, your name is not translated. I give this example uh, in class that I have a colleague in my department whose name is Kamal Sarkar. Now think of a Bengali sentence having the word Kamal Sarkar. Now if you are translating this particular sentence to English, you should not translate Kamal Sarkar to Lotus government. You should keep the Kamal Sarkar as it is. It is called transliteration, okay, or phonetic translation. So named it is should not be translated. Similarly, if I say for example, it is also very important in summarization, in question answering, in natural language inferencing task. So, for example, I say PG admission deadline, postgraduate admission deadline in Jadavpur University in the faculty of engineering or whatever. Okay. So here the most important, or say just a um, P- um, Jadavpur University. I don't know, whatever. Jadavpur University, whatever, say Jadavpur University PG admission, okay? So in this case, the most important should be given, like if this is a query that you are placing in Google or Bing search engine, most or like most emphasis, more emphasis should be given to Jadavpur University than PG admission, okay? Because any document that contains Jadavpur University can be more relevant than perhaps any document that talks about PG admission, but not about Jadavpur University, but some other university. I don't want those documents, okay? So that is why identifying named entities is an important task in when doing natural language processing. And named entity recognition is a somewhat easier task than in English, because in English you have this capitalization cue. But if you think of Indian languages, there is no notion of capital letters. Okay. And secondly, in Indian languages, most of the personal names, they are valid dictionary words. So how do you know that they? I mean, the common shortcut is a person name and not dictionary words. Okay. Maybe I will skip this slide. Okay, now I will go to some applications of natural language processing and then some tasks. Okay, so information retrieval, by information retrieval, we broadly refer to web search. So basically example of Google, Bing, and Yahoo search. Okay, and information extraction is a very broad umbrella. Under this comes a lot of different tasks and applications. So text categorization or text classification, text summarization. I think I will have a slide for each of these, so I will then explain them. Sentiment analysis, solving method problems, recommendation systems, knowledge extraction, fact checking, and so on. Machine translation, machine translation is one of the largest application areas of NLP. In fact, I did my PhD on machine translation, and while I was doing postdoc in Dublin for close to 5 years, I was only doing machine translation, and I was doing developing machine translation system for languages that I do not even know. So I do not even know which particular language it belongs to, like Russian or Romanian, which particular language. But if you just give me the data, I should be able to develop machine translation systems for that. Okay, and the goal of machine translation is to basically bridge the language gap. Okay, because most of the information that is available in the internet, in fact, I think still till today, 80% of the data available in the internet is in English. So if some person does not know English, then 80% of the information available in the web is not available to him. Okay. So this is the task of bridging the language barrier. Okay. Question answering system, again, question answering can be on unstructured data. Like by text, we refer to, I mean, when I give you a sentence and ask you to parse, there is some hidden structure inside the sentence. Okay, that is only discovered after you do full parsing. But until you do the full parsing, the structure is hidden. Okay, that is we call it unstructured data. So here the purpose of question answering is basically to build a system which can, say for example, I give you a corpus, say some text files, and it should be able to answer any question from those text files. Okay, or it could be on structured data like on database or on knowledge base. Okay, now why do we need question answering system on structured data? The answer is, if you, because you know that if you know how to write an SQL, how to access data, how to retrieve data from database, then even if the database has billions of records, if you are able to write the right query, it will take maybe milliseconds or microseconds to retrieve the data from the database or from the knowledge base. Now for knowledge base, there is a language called SparkQL, just like you have the SQL for database. For knowledge base, we have a language called SparkQL, which looks somewhat like SQL, but it is very different from SQL. The syntax and the keywords are completely different. But again, if you have a very large knowledge base, these days you have very large corporate knowledge bases, and if you are able to build a good system that can answer questions on knowledge base, then that system will be very useful. Then text normalization. Text normalization is in fact said to be a pre-processing task. In fact, say for example, you are building machine translation system. Now, if you give some input to the machine translation system and if there are some errors, spelling errors in the input, then you cannot expect the machine translation system to produce correct translation. So the first thing that you do is to basically process or pre-process the input text. Okay, so one task in pre-processing is spell checking. If a word is misspelled, then it should be corrected before you present it to a machine translation system. But these days, I forgot the name of the company. I think, yeah, it is Grammarly. So Grammarly is a business or which is entirely made up of a, basically they started as a spell checker company. Okay, and now these days they are a $1 billion company. But these days they are more focusing on grammar correction and paraphrasing. But they started basically as a spell checker system. Okay, then grammar correction is also a kind of text normalization. Then dispense detection in natural speech, because you know when you speak in natural languages, then sometimes we stutter, sometimes we start a sentence then drop the sentence in the mid of the way and start a altogether new sentence, and in that case it is like a post-processing system after speech recognition. So if you have discrepancies in the transcribed speech, those parts should be deleted. Okay, so this is a kind of text normalization system if you're dealing with speech. Some more examples. Text similarity is a big application in application domain in natural language processing. So, we start with what similarity. So we have methods for assigning similarity score between words. Then we extend this method to sentence similarity scores. So given a pair of sentences, you should be able to give a similarity score between the pair of sentences. Then you should extend it to text similarities. Okay, so given two texts, you should be able to assign a similarity between the pair of texts. Okay, some examples, applications or use cases for text similarity applications is one of the biggest application is plagiarism detection. You know, these days UGC is giving so much emphasis on anti-plagiarism. And in fact, if you write a PhD thesis, in fact, the UGC's requirement is that even for master's thesis, a plagiarism checker report is mandatory. But not all the universities, I think, maintain that. But anyways, so that is the task. So given a piece of text, you will have to basically match that text with a very large database, and you will have to find similarity. I mean, we will have to basically find whether any part of the text, of the input text has been copied from any other text in your corpus. Okay. By the way, in natural language processing, a corpus refers to a very, very large collection of text. Okay. Typically, for many applications, you need a very large collection of text. Say, for example, if you collect the like 10 years, all the news items from the last 10 years from the Andobajar News Agency, Andobajar Patrika. then that will be a news corpus, okay, on which you can perhaps define your own task. Readability assessment and text simplification. So here the task is basically, given a piece of text, you'll have to discover the readability, or you'll have to assign a readability score to that particular task, because a particular text might not be suitable for every class. Okay, say for example, you have an article on ethics in AI. Okay, now some topics or maybe applications of AI. Okay, now the text that is suitable, or the essay that is suitable for UG or PG level students will not be suitable for school students like HS students or class 10 students, because you know that these days even they have introduced AI in school. Okay, so now the task of text simplification is basically, if you find the readability score of a particular text is high, that basically means that it is quite complex. I mean, it's the other way. If the text is easy to read, then it should have a high score. And if it has a low score, then it means it is difficult to read. Okay. So if a text is difficult to read, then your task is to build a paraphrasing system which can simplify the text, okay, which can keep the content same, but can simplify the text. Then event extraction and causality. So the task of these is to basically identify events from natural language text, and then which event is leading to which event is causing which other events, or causality. Okay. Then natural language generation is another task in natural language processing. In fact, some people say that natural language processing and natural language generation are just the opposite. In fact, if you think of it, in natural language processing, your input is natural language content and you do something on it. But the classical definition of natural language generation is that your input is something non-textual, and what you produce is in natural language. Take, for example, the example of caption generation from images. So your image, I mean, the input to this is image, which is not text, okay? But you are supposed to build a system which can produce a description, a natural language description of the text, okay? In fact, if you think of this, if you think of it as a pyramid, so to the left of this, you have natural language processing. To the right of this, you have natural language generation. And on the top, you have natural language understanding. So natural language understanding is nothing but deeper natural language processing. Okay. So just like take the example of the example that I gave for I like tennis. Okay. So say for example, you have the we have uh, take the example of a machine translation system. Let's say you have asked me to build a machine translation system, okay, from English to Bengali, okay, and you have given the input sentence, I love football, okay, and my machine translation system has produced the translation, I mean, football bhalobashi. Now you would be happy with the performance of the machine translation system, right? Because I have produced the perfect translation, but here there is an ambiguity inside the input sentence, and my machine translation system produced translation has preserved that ambiguity in the produced translation, because I have not, in the generated sentence, I have also uh, uh, have not disambiguated what I love about football, whether I like to play football or love to watch football matches. Okay. So this is what natural language understanding is. If you are doing natural language understanding solutions, so typically, uh, question answering systems or natural language inferencing systems, or sometimes we call it machine NLC, natural language comprehension test. Okay, so it is kind of deep question answering text. So uh, there you'll have to put or deploy natural language understanding. So there you'll have to do deeper natural language processing. Okay, so that is basically natural language understanding. And these days we have applications where you present not just natural language content, but in addition maybe some images or some speech as additional inputs. Okay, so where you when you are dealing or when you are building systems that take inputs from multiple modality, then those systems are called multimodal systems. Say for example, I'm building an ASR system, automatic speech recognition system, whose purpose is basically to transcribe speech signal into natural language text. Okay. Now, sometimes you will see that, particularly in old movies, or not just in old movies, in even in new movies, you will not be able to understand everything what is being said, okay, because of the maybe because of the noise, or maybe because of whatever, some maybe because multiple people are speaking at the same time, maybe because the background music is so high. Sometimes you uh, are not able to understand what is being said, I mean very properly, okay. But if you have in addition provide the video of that clip, then the ASA system should be able to build a better ASA system, because you know that we as humans can lip read, because sometimes you will see, I mean, during the cricket games or football games or whatever games, sometimes you can lip read what the players are saying, okay, even though you cannot hear a single word. Just by following his lip movements, you can understand what the user is saying, okay. So if in addition, if you present both the video as well as the speech, then the ASA system is supposed to produce better quality transcriptions. Okay, that is in fact multimodal processing, an example of multimodal processing. Text classification is a very broad task, where the task is basically, I mean, now depending on the predefined set of classes, you can have many different tasks. In fact, in these days, you have hundreds of applications of text classification. So, say for example, assigning subject categories or topics or genres to text. Spam detection was one of the earliest application of text classification. So, given a mail, you'll have to say whether this is a spam or not. Then authorship identification, given a text, you'll have to basically say who is the author of this particular text. Okay, you might think that it is very difficult to um, develop such a system to understand who is the author of the particular system. But if you provide enough data to the classification system, to the machine, then the machine should be able to identify uh, the author just by doing simple text classification task. Again, age, gender classification. Again, you might think that it is impossible to identify the gender just from the writing, but people have also shown that it is possible. Okay, if you produce the, I mean, if you present the text classification data like these texts are written by male authors and these texts are written by female authors, and if you present enough data as training data to the text classification system, then it should be able to identify the gender of the author. Okay, similarly, age classification or like age group classification. These days we have an application called hate speech detection, which is a very like recent task and very very pertinent task with respect to social media applications. You know, these days Facebook sometimes flag news items. Even if you have written a perfect, there is no hate speech, nothing, but still Facebook flags you as a potential hate speech, and it flags. It does not post immediately, but it basically means that that particular hate speech classification system is not good. Okay, so in fact, the posts that are identified as potential hate speech by Facebook, they are manually validated. Okay, and then either they ban or they allow to post that particular post. Okay, similarly, personality identification, even language identification, because many there are many languages that share the same alphabet. Okay, so, given a sentence, you'll have to basically say in which particular language it is written. This is a very easy task. It can be done just by looking at a few n-grams from the beginning. Sentiment analysis. I think I have a slide on sentiment analysis, and then there I'll describe it. In speech processing, the core tasks are automatic speech recognition. So these are the two core tasks in speech recognition. So in speech recognition, your input is speech, output is text. But in the speech synthesis, your input is text and the output is speech. Okay, maybe in a male voice, maybe in a female voice, and usually you will find many different speakers. So if you have if I searched with like pronunciation for a particular word, if you go to a particular system, you will find multiple signals for that particular word. Maybe one read out by male, maybe one read out by female, maybe by both by two female persons, but with different voices and so on. Okay, but there are some additional tasks in speech processing, like for example, speaker identification. Now, speaker identification is not a NLP task. Okay, it does not have anything to do with language. So you are not doing any language processing here. So speaker identification is considered as a pattern recognition task. Okay. Then speech digestion basically involves speech recognition plus speaker identification. So here uh, you need to discover who is saying what. Okay. Say for example, you have the recording of a minutes, sorry, you have the recording of a meeting, some kind of BOS meeting or some meeting. Okay. Now you want to build a system. Now you have a system that can do ASR, okay? So maybe with 100% accuracy. So you have all the text, but you do not know which part was said by which person, okay? So you will have to build a system that can say that person one is saying this, then followed by person two who says this, then again maybe person one. It does not have to be very specific about the person because it does not know about which part exactly. I mean, say for example, this part is being said by Mohidul, this part is said by me. It does not have to say that. It just have to say person one is saying this, person two is saying this, person three is saying this, and so on. Okay, just like in a play, if you have ever read a play, there will see person one is saying this, person two, and so on. Then again, language identification is also a task in speech. And in fact, if you have sometimes noticed in YouTube, because I sometimes I mean use subtitles in while I'm watching some YouTube content. Okay, um, because maybe it is being said by some non-native speakers and some of the words I cannot follow. So then I use the subtitling. But sometimes you will notice that even if you press the subtitle button, CC button in YouTube, it produces garbage subtitle because it does not identify the correct language. It happens. I mean, I have seen it multiple times. So this is the person is saying in English, but he has a very strong South, maybe Tamil accent. Okay, and the automatic language identification system, it identifies that the person is saying in Tamil, so it generates the content in Tamil. Okay, so this is the difficulty with speech recognition. In fact, the for speech recognition system, because you know that they are language specific. I mean, I mean, say for example, you have built a ASR for an ASR for English, that will not work for Bengali. That will only work for English. Okay, if you want to put that ASR to Bengali, you will have to build a separate ASR. I mean, you don't have to build a separate ASR. So maybe the model can remain same, but you'll have to retrain the ASR model. Okay, for Bengali. But the thing is, I mean, for ASR, first you will have to set the language, then the ASR works. Okay. So if you cannot, even if you have ASR systems for multiple languages, if you cannot properly identify the language in which the speech is being made, then your ASR is of no use. Okay. Then normalization of ASR. So it is kind of like the post processing of ASR output. So sometimes we say that, let's say I say this, we have 12,578 students in Jalapur University. Okay, so I said 12,578. So exactly 6 tokens. Okay, but if you build an ASR, so it will produce this exact 12,578. These 6 tokens written in like in English, not in numbers. Okay, but typically if you write this, then you should write it as 12,578, right? Not as 12,000 and so on. So those things are called like normalization of ASR. And then again, in speech, we have so much dissonances. So you should also ideally put some dissonance detection on the ASR output. And then again, dialogue systems, you know that, in fact, the grand challenge of natural language processing is to build a sophisticated dialogue system that is able to beat Turing challenge. Because I hope you all know about Turing challenge, which is said to be the grand challenge in AI. Okay. Now, if you want to build a system that can beat the Turing challenge, then you will have to basically solve a very, very sophisticated NLP system that can do, say, for example, the person is not typing, but instead he or she is saying. So then in that case, you'll have to build a speech recognizer. Okay. Then you'll have to build a machine. Maybe the system is, maybe you can, maybe you want to build a Turing system where the person can talk in any language. Okay, then you will have to employ or deploy machine translation systems. Also, Anaphora systems and parsing and NER, all these intermediate tasks and application you'll have to put into a big system that can beat the Turing challenge. Okay. In basic text processing tasks, like in just if you're building an application, you will have to go through a series of pre-processing tasks. So just like that in NLP, we go through a series of pre-processing tasks. So given a text, first we break the text into sentences. This is called sentence segmentation. Because think of a parser. The input to a parser is a sentence, not a whole text. Okay. Similarly, given a sentence, the next task is to basically break it down into tokens, which are typically words, but not always words. Okay. So this is called tokenization. Now you might think that tokenization is very easy for English or other Indian languages, but it is not easy for Chinese or Japanese, even for German. Okay. Because in German, you have the phenomena of noun compounds being a single word. Okay. So life insurance, employee corporation will become a single word in German. And if you think of Chinese, the entire sentence, there will be no punctuation. I mean, there will be no space or nothing whatsoever in an entire sentence. Okay. Then normalization, like I said, you'll have to do some kind of spell checking or that kind of thing. Then lexical analysis, just like you do lexical analysis in compilers, you'll have to do some kind of morphological analysis for every language. So lemmatization is the task of bringing words or surface words to their dictionary headword form. Okay, so dictionary headwords are basically referred to as lemmas. And if you take the raw text, I mean, these are basically tokens. Okay, comes, coming, came. These are the tokens that appear in the text. Now, say for example, you are building a very simple machine translation system. It does not have any ingredients. It is very simple dictionary-based machine translation system, word for word translation. Now, even if you have a dictionary, it is of no use if you cannot bring the word came to come. Okay, because say for example, you are learning English for the first time. Okay, you have a dictionary. I'm assuming that you are a Bengali. Okay, so you have English to Bengali dictionary. Now, even the dictionary is of no use if you do not know that the lemma for the word came is come. Okay, so the meaning of came, you can get that meaning of came from the entry of come. Okay, that's the task of lemmatization. Okay, or there is also called task called stemmer. Bringing surface words to layers to stems. Stem is a different concept, so it's like somewhat like dhatu concept in Paninian framework, but it is not exactly like the linguistic stem. Okay, but it is mainly used in information retrieval only in information retrieval or search engines. Then morphological analysis. Take for example the word bolechilam. Okay, first I'll give an maybe a English example, and then I'll give an Bengali example. Okay. So if you have the word on successfully, okay. So if you break it down into morphemes, so in morphological analysis is basically the study of morphemes. So morphemes are the bits and pieces that make up a word in the language. Okay. So in the morpheme, I mean, after the morphological analysis, you will have the set of morphemes, and the core meaning bearing unit is called the stem or the lemma, and the morphemes that appear before the stem is called the affixes, and that appears after the lemma are called suffixes. Okay, so after doing the morphological analysis, you should be able to break the word into unsuccessfully. Okay, and if you are able to break the word unsuccessfully into its corresponding morphemes, then you can also build this. I mean, then it's basically easy to identify the meaning of the. I mean, say for example, you have a dictionary which has the word success, but you in that particular dictionary you don't have the word unsuccessfully. But by analyzing the morphemes, it is very easy to identify that full basically what it makes is that it takes a noun and it makes the adjective form. Okay. Similarly, ly, what it does is that it takes an adjective and it makes an adverb. Similarly, on prefix, what it does, it takes a whatever, maybe an adjective or noun, okay, and it makes an antonym, okay. So by analyzing these morphemes, it is very easy to identify the meaning of the words. Similarly, take this Bengali example, bolechilam. So I did not know about this until like a few years ago when I was speaking to the director of School of Language and Linguistics in Jadavpur University. So he basically said that bolechilam, the word bolechilam is made up of like this, okay. So you have bol, then you have, I don't know exactly what's the functionality of this particular suffix, but every suffix has a functionality of its own, okay. So it gives a new notion of meaning to the new word, okay. So I mean, when the word is bolecho, so every perfect tense word ends with a cho, okay. So ami bolechi, tumi bolecho, tara boleche, okay. Then this e is the person marker, ami bolechi or amra bolechi, okay. It basically makes it the first person. When lo is added, it becomes a past tense, okay. Bolechilo, bolechile, bolechilam. So everything, all the past perfect verb must end with a lo, okay. Similarly, again, it makes it a first person, okay. Then if you go into syntactic analysis, one of the first tasks is basically POS tagging. So you will have to assign a POS tag to every word in the sentence or every token in the sentence sequence. Okay. Now you know that in English or in I mean in general it is considered that there are 7 part of speech. And now there is a thing called Stanford POS tag set, which has 52 tags. It is like a fine-grained POS tag. So take for example, this NNP basically means proper noun. Okay, this NN is just a noun. Okay, a plural noun has the tag NNS. Similarly, VBD is verb participle in past tense. VBG is like a gerund, like if a verb ends with ing, it is verb gerund, and so on. So I think I took this output from the Stanford POS tagger. So this is proper. It says it is a proper noun. It is verb participle. It is a um, pronoun in possessive pronoun, because you can have possessive pronoun and then like he, him, and his. So 3 different forms of pronouns. Okay, noun, determinant, noun, and so on. Then once you have assigned the POS tags to the words in a sentence, then you can easily build a parser if you have the grammar, or if you have a like a tree bank. We call tree bank the training data for building a parser. Then you can easily build a top-down parser or bottom-up parser to generate the grammar for that particular language. Okay, and then that parser should be able to parse any sentence in that particular language. Okay, so given the same sentence, if you have a proper parser for the English, I think I took the example from Stanford parser again. So it should look like this. So here in this particular case, the lip nodes are the words in the sentence. So if you traverse the lip nodes from left to right, you will get back the original sentence. Okay, and just above the lip nodes, you have the like the POS tags. So with this NNP, BPT, PRP, NM. We go to the previous slide. So these are the POS tags. Okay, and above them there are some intermediate tags. Okay, and this is nothing but the bracketed form of the parse tree, because if I give you a tree and if I ask you to write the tree in a text file, how will you do this? You cannot draw a tree in a text file. Okay, but you can store the text file. I mean, if you can store the tree in a bracketed format. So whenever a bracket left bracket tokens, you create a new token. So like root, then S, a new token, NNP, a new token, NNP, another new token. And then you do not have a new bracket. So you know that this node is a lip node, JetBlue. Okay. And then you have 2 brackets, the 2 closing brackets. So you go 2 step up. Okay. Then create a new node, VP, and so on. Okay. In this way, you can represent a tree in a bracketed format. Now, how we can build a parse trees? Now, for this, you require a training data for parser. Okay, building a parser. So basically, what you need is a uh, training data. I mean, basically, say for example, you want to build a parser for English. So what you need is a lot of English sentences already parsed. Okay, and this data is called. This data basically serves as the training data for building the parser. Okay, and this data is typically called the Treebank data. Okay, in fact, I was also involved in a Treebank project which was being developed for Indian languages. Um, so I think we developed the Treebanks for like Bengali, Hindi, Malayalam. There was IIT Bombay, IIIT Hyderabad, and Nicole University, I think. Anyways, let's take the example of English parallel English tree bank, okay, where you have only, let's assume only two sentences. You have only two sentences first. Now you do not start with the grammar, but you can easily discover the grammar rules. So first you look at what are the different grammar rules or association rules that you have seen being applied in this particular tree banks. Okay, so you have this S to NPPP, PP to BPPP. You have all these same this all these rules being applied in the tree bank. Okay, so you list them out. Then you count the frequencies. So how many times you have seen S to NPPP being applied? Okay, twice, and so on. So you have count their frequency of every rule being applied, being seen to be applied in that event. Okay. Then you count the probabilities. So let's say what's the probability of this rule being applied? Okay. Now the thing is you have seen the S twice. Okay. And among them, this rule have been applied twice. Okay. So it means that the probability of this rule being applied is 2 over 2, which is 1. Okay, but if you think of, say, for example, NP to NPPP, I think, where is this? NP to NPPP, this rule has been seen only once. Okay, but in the entire tree bank, you have seen the NP appearing 7 times. Out of that, only once this rule was applied. Okay, so the probability of this rule being applied once you see an NP node is 1 over 7. Okay, in this way, you can build a probabilistic context-free grammar. Okay, so at the end of this, what you have already discovered from the tree bank is what we call PCFG, which you can apply to build a top-down parse tree, a bottom-up parse. I mean parser. Okay. Then in NLP, we have something called dependency parsing, which is somewhat different from parsing that we just said. So it is, I mean, this parsing is said to be constituent parsing, and this parsing is said to be a dependency parsing. Let me open. Uh, Yeah. So in dependency parsing, the nodes themselves are the words. Okay. In case of dependency parsing, that is not the case. The words were only the lib nodes. Okay, and all the other nodes were some intermediate nodes and the POS tags. But in case of dependency parsing, is entirely made up of nodes which comprise of only the words. So let's say, for example, you have the sentence he or Ram eats rice. Okay, so you'd have a dependencies tree which is it's this is Ram and then this is rice. Okay, 3 nodes. So the verb is typically the predicate of the dependency tree. So it will be at the main verb. Okay, will be at the root of the dependency tree, and it basically says that this is the subject. Okay, every age is labeled. Okay, this is object. So it says that Ram is the subject of it and rice is the object of it. So if you have a sentence and if you can then have if you have the dependency parser, which can produce the like the perfectly valid dependency parser, then it is very easy to build a question answering system based on this. Okay. So here I think we have example of taken from two different parse trees. So these are just flattened representation of the parse tree. Okay, so we'll notice that this particular word does not have any incoming arc. Okay, incoming edge. So this basically means that this is the root of the parse tree. And similarly, it says that jet blue and cancelled what? Cancelled flight and our flight. So this is the modifier, and this is the modifier. This is also the timing modifier, temporal modifier. Okay, this morning and so on. In fact, you will notice that the reason I placed two different parsers is because these are produced by two different parsers, and I noticed that they have somewhat different. They have produced somewhat different parsers, but both of them are valid. So in this particular sentence, late is connected with cancelled. Okay, so this sentence has the meaning that as if the cancellation happened very late. Okay, but in this particular sentence, you will find that late is connected to was, then it is flight, and then cancelled. So in this particular sentence, it basically gives the meaning that JetBlue cancelled our flight, okay, which was already late. So in this particular sentence, it has the meaning that as if the cancellation happened very late, but in this sentence, it has the meaning that as if the flight was very late, and that is why JetBlue canceled the flight. Okay, so two different meanings, but nonetheless, two different valid purposes. In semantics, yeah, I already said that semantics basically deals with meanings of words, and because words are ambiguous. In fact, most of the words that we use in a daily basis in our life are very, very ambiguous. Okay, rare words, they typically have very less meanings, or typically they are monosemous words. But most of the words that we use very frequently in our life, are almost all of them are very, very ambiguous. Okay. So here the task of, I mean, here we have three basic tasks. So the first task is, given a polysemous word, given that a polysemous word appears in a sentence, you will have to identify which exact meaning does it have, or which exact meaning you should use for that particular word. Okay. Then the second task is semantic similarity. So like I already said about text similarity. So here it basically deals with assigning similarity between a pair of words and then extending it to sentence similarity and then extending it to text similarity. Okay. And then another task is word sense induction. This is also called kind of like unsupervised word sense disambiguation, because in word sense disambiguation, we assume that you have a dictionary. Okay. You do have a sense inventory. So it is like a text classification task. So when you're doing text classification, you have to know in prior what are the classes, right? Just like that, in word sense disambiguation, before you can disambiguate a word, you will have to first know what are the senses that this particular word belong to. Okay, and then you can have the word sense disambiguation module. But in this particular case, word sense disambiguation, you do not even need a dictionary. Okay, so you think of it as an unsupervised word sense disambiguation approach. Okay, so think of like this. Like, so typically the way it works is that you typically collect a very large corpus, and from there you try to automatically derive the meanings of new words and the similarity of words. Okay, I will give an example of this. But another example is this: take the example of like a tablet. Okay, now I'm pretty sure you must have a dictionary at your home. Try to find out the meaning of the tablet. And the most I mean, in fact, these days we use the word tablet in the electronic device sense more than in the medical sense. Okay, and you will not find the electronic device sense in the dictionary. Okay, so you'll have to find a or you'll have to devise a method which can say that, say for example, I say that the sentence is, I went to the mobile store and bought a new tablet which has this specification, blah blah blah. Okay, so given that this particular sentence, the word sense induction module should say that even though there is a different sense of tablet in the dictionary, it should say that this particular mention of the word tablet is perhaps not listed in the dictionary. Okay, so this belongs to a new meaning. Okay, so as if it is inducing new senses of words or discovering new senses of words. So this is what is word sense induction. Typically, this is a much more difficult task than word sense disambiguation and semantic similarity. So in semantic similarity, we have something called distributional models of meaning, or vector space models of meaning. So where I mean, the meanings of words are identified based on their context. Okay, because I'll just directly go to the example, because we are almost spent 1.5 hours. So does anybody know the word tesguino? I hope not. If you have not seen this slide, then you do not know the meaning of tesguino. It is a very rare word. Okay, but look at the following sentences. A bottle of tesguino is on the table. Okay, so perhaps now you know that Tesguino is some kind of liquid. You are not sure yet whether it is a drink or not. Everybody likes Tesguino. Now it looks like perhaps like a popular drink, or soft drink, or you don't know whatever it is. Tesguino makes you drunk. Now you know that it is a alcoholic drink. We make Tesguino out of corn. Okay, so now you know that it is kind of like, I don't know what drinks are made out of Coca-Cola, like beer or something, or I don't know. Okay, so you did not have any idea about the what is going on just 30 seconds ago. Okay, just by looking at this four sentence, you have a pretty good idea about what is going to mean. So this is the notion of distributional word or distributional semantics. Okay, you derive the meaning of the word based on its context. So what kind of words are appearing at its context, and based on that, you derive the meaning of the word. Okay? So take this example. So this we have this distributional semantics. We have this called term context matrix. Okay. So these red words are the terms. So terms are the words that appear in your corpus. Okay. And these blue words are the context words. So the words that appear in the context of a particular word. Okay. So we typically define a plus minus 10 words or plus minus 5 words context. So plus minus 5 words context means 5 words to the right, 5 words to the left. You consider these 10 words as your context word. Okay. So you analyze your corpus and you collect these context statistics, which word appears how many times in the context of another word. Okay, so this is your term context matrix. So this is in fact called the term vector. So this gives you the distribution of context words in the context of this particular term record. Okay. So now if you compute just the cosine similarity between apricot and pineapple. Now, by the way, so this is just a glimpse. Now this term context vector is typically very large. So if your corpus has 10,000 unique words, so this is a 10,000 cross 10,000 matrix. Okay. But the important thing to be noticed here is that if you are able to compute this, and then if you can simply take the vector similarity between these two, then it should give you a pretty high degree of semantic similarity between these two words. Similarly, if you look at the distribution of context words between digital and information, so if you compare the semantic similarity between digital and information based on this very simple approach, I have not discussed the entire approach. We have this concept of PMI, point towards mutual information, and positive point towards mutual information, and so on. Forget about all those things. Just by collecting these corpus statistics, if you employ a cosine similarity approach, I mean similarity, if you simply employ cosine similarity, then that will give you pretty high degree of semantic similarity. In fact, you might have heard of, I mean, if you have not heard of what to fake is the very reason that we have um, we have found so much success these days with deep learning, because it's not that a neural network has not been earlier applied for natural language processing, but after what2fake came into being, we made proper sense of deep learning based approach or deep neural network based approach. So what2fake was developed by Google. So it represents each word as a very dense, low dimensional vector. So it is just like this. It is just like considering the term vector of a particular word, but then assign, what2fake or these word embeddings, they basically assign a very dense representation or low dimensional vector to every word. Okay. It uses a shallow neural network with a single hidden layer, and it is trained on the entire web corpus, so the entire English corpus that is found in the entire internet. Okay, and there are two main architectures. One is called the CBOW, the continuous backup words, and the one is called SkipLab. In one approach, take for example, you have this. So you have this. So given a word, you will have to identify its context. This is one task. Okay, and the other task is you have W1, W2, W3, or maybe W4 and W5. Okay, so here you'll have to, given this W1, W2, W4 and W5, you will have to, given these four words, you will have to identify this gap. I mean, which word should appear in this gap. Okay, these two different approaches. And then the beauty about the word2fake approach is that the author of that paper, which was published in 2013, they showed that even it captures the semantic relationships between words. In fact, if I ask you this question, that king minus man plus woman. Take this as a like a aptitude question. I mean, what should be the word? Then you should. I mean, as a human, if you're an intelligent human, you should be able to tell that it should be queen. Okay, king minus man plus woman, so it should be queen. Similarly, like prince minus man plus woman, it should be like princess, right? Right. So in fact, they showed that if you take the vector of king and if you subtract the vector of man from this, and if you then add the vector of woman into this, then the vector that you will get will be very similar or almost close to queen. Okay, they in fact showed that there exists this kind of relationship. So the direction between the words, okay, shows the relationship between the words. So man to man, king to queen, prince to princess, and so on. Similarly, there also exists relationship between the verbs. Similarly, between the cities and their, I mean, sorry, countries and their capitals, and all these types of many different types of relationships. Okay, and some more tasks, some more core task. In here, I have already told about named entity recognition. I think I have, yeah. Then Anaphora resolution, I've already told about this. Textual entailment, or which is also called these days natural language inferencing. Maybe I'll just note that. Yeah, natural language inferencing. Then paraphrasing. Paraphrasing is basically given a text, you'll have to rewrite the text so that the meaning remains the same, but you get a new text. Similarly, entity disambiguation. I'll give you an example of entity disambiguation and so on. So the task of named entity recognition is to basically find the mentions of names and then classify the mention of names. Okay, classify them typically into 4 different classes. Typically for any year, we consider the person, organization, location, and everything else into miscellaneous. Okay, 4 classes. So we first identified that these are the names, these are the proper names. Okay, but it is not just identifying the proper names, it is also about classifying them into proper classes. Okay, so then you say that Andrew Wilkie is a person, this is a date. So date is basically considered a miscellaneous. Okay, these are person names, and this greens is an organization name, and so on. Okay. Typically, it is said to, I mean, it is approached as a BIO tagging problem. So BIO is a conal format, CONL format. So they introduced this BIO notion. So the idea of BIO is basically, I mean, linear is typically considered as a sequence leveling task. So say sequence leveling task is that given a sequence of words, a sentence is typically considered as a sequence of words. Okay. If you have to label every token in the sequence to some predefined text, then this task is said to be a sequence leveling task. Okay, let's take for example the POS tagging task is said to be a classic example of POS tagging task. Similarly, NER is also typically approached as a POS tagging task. Okay, in this case, so B represents the beginning of a token. Beginning of a named entity. I is continuation of a named entity. Okay, so as long as you have I after a B, so that basically means that the named entity is continuing. And any word that is not a part of named entity is represented by O. Okay. Then entity resolution and linking is, you might have many person by the same name. Okay. In fact, I found that Kevin Smith is a or famous person. There are many entries in the Wikipedia by the name Kevin Smith. Okay. So then this Kevin Smith is, I don't know what it is. So I think he's a famous musician. Okay, this Kevin Smith is a famous footballer, American footballer. This Kevin Smith is a actor. This Kevin Smith is a writer, and so on. Okay. In fact, I was looking at Kevin Smith in Wikipedia. In fact, I found that there are many players, not all of whom are football players. Okay, in by the name Kevin Smith in America. Okay, in fact, there are many American football players by the same name Kevin Smith. Okay, here your task is to basically identify the person name and then linking it with the proper knowledge base entry. Because in the Wikipedia, I will show you. Maybe Kevin Smith Wikipedia. Okay, so in fact you can see that there are so many entries by the name Kevin Smith. Okay, and each of them, like say for example, I take this one, has a entry in the Wikipedia. Okay, now this thing that you can see on the right of the every Wikipedia page is called infobox. Okay, now this is powered by DBpedia, which is kind of the like the knowledge base for Wikipedia. Okay, so I mean, here your task is to basically identify the named entities and then resolve which exact person or entity it is referring to, and then link it to the appropriate knowledge base. Okay. Textual increment, here the task is to give in a pair of sentence, which one is called typically called T and the other is called H. Okay. So typically T is a long sentence and H is a short sentence. And if the truthness of the sentence T decides the truthness of the sentence H, then it is said that T is textually entailing H. Okay. It is written as T is textually entailing H. Okay, so this is textual entailment. Take for example the sentence ABC was murdered by DEF on this particular date in this particular place during this particular time and so on. Okay, and this is the sentence T, and the H is the hypothesis is ABC is dead. Okay, now you know that if the previous sentence is true, then the following sentence must be true, because we as a human make these inferences that a person who has been murdered is no more alive, he's dead, he or she is dead. Okay, so it is also, that is why it is also called natural language inferencing task, but earlier it is to go by the name textual entailment. Now there can be typically it is considered as a two-way classification task, either there exists an textual entailment or not. Okay, but now it has been modified into a three-class classification problem. It either textually entails or it can contradict or maybe unknown. Okay, there are some examples. I'm not going into this, and this is one example. I mean, I think this slide is pretty old. I mean, I don't, but I have tried to update this slide. Anyways, so when I was doing PhD, I mean, I did my PhD in 2008. I mean, I got my degree in 2009 though, but I joined as a postdoc in 2008. Anyways, that time I had to face the question, what you will do, why you are doing this silly stuff, why you are doing natural language processing. Nobody does NLP, there is no job in the industry. And in fact, that was the case. Then only, even Google was very young company then, okay, in 2006, 2007. Only Microsoft, there are only a few big corporations like Microsoft Research and Xerox and IBM Research and Yahoo. Only I think these companies who were doing NLP, and you'll have to like get a PhD from a renowned institutes in Europe or USA to get a place there. Otherwise, NLP was not. NLP was only being done in the academic sphere, not much in the industry. But these days, everyone is doing NLP. All the companies. If you take the example of like Facebook is such a big name in these days in NLP. Tencent AI Labs is a big data analytics company. Baidu is kind of like, I mean, Baidu is a big Chinese company. They see themselves as the rival of Google. Like they are an internet giant, uh, but they are doing a lot of, just like Google is doing a lot of NLP research, Baidu is also doing a lot of NLP research. These days you have OpenAI. In fact, you have perhaps heard of OpenAI in the last 2 years, but OpenAI has revolutionized NLP in the last 2 years. Oracle was doing some NLP. Basically, it was question answering on database. Yahoo used to do a lot of NLP, but these days, Yahoo has broken up. Nuance was one of the earliest companies who was doing natural language processing, sorry, natural language generation. And I think in 2017 or 18, I read a news article, an interview of the CTO of Nuance company. And there he mentioned, even in 2018 NLG, or natural language generation, even 2 years ago, natural language generation, just before, I mean, before LLM came into being, so like 2018, 17, 18, NLG was not, the state of the art in natural language generation was not that good. And I had a paper in International Natural Language Generation Conference in 2016. And there, during the question answering session, I made during my reply, I said that, the question was about giving the same input, whether my system produces different outputs so that it is not so boring to read. My reply was that, first of all, it was not, we did not have that system. So, but I said how it could be, we can change that system to build a system. But then I said that we have not reached such a state in natural language generation where we should bother more about having less boring content than having proper content. Okay, but the scenario has changed in the last few years, I think. Anyways, information extraction is like, say, for example, the book that is followed the world over in natural language processing as a like the course book, a textbook for any natural language processing course. We teach NLP at Jadavpur University, both in the UG and the PG level. In fact, I teach them. And the book, this book by speech and language processing book by Jurafowski and Martin, Christopher Martin, is considered to be the textbook across the world. So consider this mail written by Martin to Jurafowski. So if you have a good information extraction system that can identify that, like this mail is talking about a meeting which is going to be held in Gates 159, and it is going to be held in tomorrow, that is January 16th from this time, and it is about the curriculum meeting, then it would be very beneficial and to have this structured information and populate this in your calendar, right? I don't know why Gmail does not do this, but it is not so difficult to do this. If I had access to Gmail, I would do this easily. Sentiment analysis. Consider this example. Let's say you are thinking of buying a camera, and then what you do is, first of all, you choose a few models, but then you cannot decide about which exact model to go for. Then what you typically do these days is go to internet, you look about the reviews available for those particular models, and so one of the objective of sentiment analysis is to automatically identify the attributes or important criteria, important features about that particular product or service. Okay, so for example, when it comes to camera, it identifies that zoom, affordability, silent, weight, flash, and ease of use. These are the important features that the user are talking about. Okay, then let's say about size and weight. Someone says nice and compact to carry. Now you know that your sentiment analysis system should say that this is a positive sentence. Similarly, the next one, but the camera feels filmy, is plastic. It is the user is being negative about the camera, so this is a negative comment. Okay, and then if you can aggregate these sentiments, okay, like this, then it becomes very beneficial for the user. So it says that almost 100% of the users are satisfied with the flash. Maybe about 60% of the users are satisfied about the ease of use. Okay, so it gives you a very, a very informative information about the camera. Okay, so if you are a person who does a lot of night photography, so if flash is a must, then this is perhaps the camera that you should go for. But if you are a amateur person who does not know much about photography, so this is perhaps not the camera because it has got a very low score. As far as the users are concerned, they are not so happy about the ease of use. Okay, now this kind of information becomes very useful both from the user perspective as well as the company perspective or the service provider perspective. So if I was the owner of Nikon and if this was a Nikon model, okay, then and if I had this information, okay, then I should worry about the ease of use feature about this particular model. Okay, so for the next version of this model, I should improve the ease of use or the usability feature. Okay. Then there are some advanced topics in sentiment analysis, like I said in the previous slide. There's these attributes. Okay, so this is called aspect-based sentiment analysis. So not just sentiment identification is important. You also have to identify what the user is saying about. Okay, which exact aspect. Say for example, the food was great, but the service was pathetic. Okay, you cannot simply say that this sentence is positive or negative, because the user expresses both sentiment, both positive and negative, in this single sentence. Okay, so the user is positive about food but negative about service. Okay, so this is aspect-based sentiment analysis. Then it is also important to identify the subject. I thought the food was good, but my friend felt otherwise. So here I felt that the good was okay, maybe good, but my friend did not like it. Okay, so it is also important to identify who is expressing the sentiment. Okay, then sarcasm and irony detection is a very difficult task in sentiment analysis, because in sarcasm, what happens is that apparently what you were saying sounds very positive, but actually you were saying the reverse, just the reverse. Okay, but how even identifying sarcasm becomes difficult for a human perspective. Okay, sometimes I say something sarcastically, but you are not able to get that. Okay, you might think that I'm saying very positively about you, but actually I am being sarcastic. Okay, so it is very difficult to identify sarcasm from text. And then argumentation mining is kind of like analyzing debates. So in debates, you have these two parties. One is for the something and one is against something. But then I think you'll have to then automatically have to identify what the teams are saying against and in favor of for something. Okay. These days I have been very interested in social media, analyzing of social media. And in social media, you will have to face this phenomenon of code mixing. In code mixing, in language, in terms of natural language processing, the code means the alphabet. Okay, the set of letters that you have in that particular language. Now, in code mixing, we borrow letters from. I mean, we borrow like words from other language, because these days, if you think of the particularly the Indian scenario, whenever we speak, we do not speak in perfect Bengali or perfect Hindi. We always mix with English words. Okay, so that is called code mixing and code switching. So think of this particular sentence, and you have this particular word in this sentence, and then you have something before this and after this. Okay. Now let's say you are building some kind of a machine translation system or question answering system on this. Okay. Let's say you have some WhatsApp corpus. Typically in people in WhatsApp, they write very fast and they do not bother about using. Typically, most of the people use like Roman keyboard, the Latin keyboard in the WhatsApp. So first of all, what are the possibilities for this particular word? First of all, this word is a valid English word. The poor means a tiny hole. But if it was Bengali, then it can mean pore. Okay, pore can have, again, pore means later, or pore means to wear something. Pore. Okay, say he. It could mean pore means wearing a jacket. It could mean pore means, again, he reads a book or like something, pulling something. Okay, or it could mean pure. So you have all these possibilities if the word is a Bengali word. Okay, but considering all these possibilities, like both the English and the Bengali, what if the word was a misspelled word? Because these days, when we are discussing something in the social media, because we type very fast, we do a lot of spelling mistakes. Maybe the word was sport, original word, or maybe the original word was bore, or maybe something else. Maybe this was the result of a spelling mistake. Okay, so you'll also have to take into consideration that factor. Okay, so now it becomes extremely complicated to analyze this. Like you are not even sure which exact module, whether the language identification module should come first or the text normalization module should come first. Okay, and then you'll have to accordingly take decisions. Mohidul, how much time do I have? I think I still have few slides, so I can end here.
Yes, yes, sir. You can continue.
Okay. So maybe I'll take another 15-20 minutes and then I'll wind it up.
Okay, sir. No problem, sir.
A question answering system, if you have heard of the Jeopardy challenge, so it is like the counterpart of KBC. In fact, KBC was inspired by Jeopardy, I think. I'm not sure. But it is like, so you have a buzzer and you have some contestant. So you'll be asked questions, and whoever presses the buzzer first, he or she gets the chance to answer first. Okay. And the champion of the Jeopardy challenge is said to be the living encyclopedia. Okay. And since the Jeopardy challenge began, there was a person, I forgot his name. He won the Jeopardy challenge for 7 consecutive years, and he is said to be the living encyclopedia. And IBM Watson, just like you know, must know about the Deep Blue. IBM built a supercomputer who beat the then world champion in chess, Gary Kasparov. Just like that, IBM built a supercomputer just to build a very sophisticated question answering system, which is called the IBM Watson system or Watson server, which won the Jeopardy challenge in February 16, 2011. Okay. Now you can, I'll give you an example of the kind of questions that are given in the Jeopardy challenge. And from that, you'll be able to understand how difficult is the challenge. Okay. I'll give you 10 seconds or maybe 15 seconds to read. Okay. Exactly 15 seconds. Could you read? Yeah, I'll go to the previous slide. Can anybody tell what was the meaning of this particular sentence? Yeah. So the sentence was about, not a sentence, but it was a question. So these questions specifically ask about the name of the, basically you as an participant in the Jeopardy challenge have to tell the name of the person who wrote a famous novel and which that famous novel inspired this particular novel. Okay. So now you can think of the complexity of the question itself. Okay. Just to analyze the question, a person needs some time. Okay. And even what is the expected answer? Forget about answering the exact answer. What is the expected answer? The expected answer is to, you have to name the person who is the author. Okay. Who then wrote something famous novel, which then inspired this particular novel and so on. Okay. So you can, the name of the person is Bram Stoker, who wrote Dracula, which inspired this particular novel, and that is a expected answer. Okay. So now you can imagine how difficult is the Jeopardy challenge. Okay. Now you know about Apple Siri. Apple Siri is nothing but a question answering system, but it's basically a knowledge-based question answering system. Okay. So Apple has a knowledge base, and it takes the question and then looks at the knowledge base for the answers, and then it produces the answer. These days, almost every company has a knowledge base, like all the big corporations, be it Facebook, Google, Yahoo, and all the companies, Apple. Okay. Types of question answering system. I will not go into the like how it is done, but just give you a flavor of what is question answering. Typically, there are two types of question answering system. One is called factoid question answering systems, QA systems, which is like answering who, what, when, where, and I think 5W. I'm forgetting the last one. Anyways, so basically the answer to these questions are very short, typically a word, single word, or a phrase, typically a noun phrase. Okay. Then procedural question answering or complex question answering, typically why and how kind of question. Okay. But again, you can frame the question like, what do you think? Like, so basically the answer has to be a broad answer, and it might also involve a procedure and so on. Text summarization, there are three types of text summarization. Depending on, okay, first of all, you can have, depending on what to summarize, you can have two different types of summarization. Either the input to the system can be a single document, in that case, it is called single document summarization, or it can be multiple documents on the same topic. Okay. Say, for example, I provide you a multiple text files on Sachin Tendulkar, and then I write you to write a summary on Sachin Tendulkar. So that is multiple document summarization. Okay. Then type of summary, it could be generic summarization. I just provide you the document and just ask you to summarize it. Or it could be query focused summarization. Say, for example, I ask you about writing a summary about Kejriwal's view on NRC. Okay. So I'm not writing. I'm not asking to write you about. I mean, of course, there are some documents based on which you will produce a summary. So it is not generic summarization, and it is also not about NRC. It is also not about categorical. But I'm exactly specifically asking about producing some content about what Kejriwal thinks, or his party thinks about what. I mean, whatever is what is his view on NRC, because I mean, he's still not very clear yeah, about his views on NRC. Okay, so that is query focused summarization. So you have to build a summarization system which takes text as well as a query. Okay, so it is a kind of question answering system, but essentially it is a query focused summarization. Then, as far as methods are concerned, you can have two different types. Earlier, people used to work on extractive summarization, which is kind of very easy, like a undergraduate project. Not even a project, it's just like an assignment. So here, given a document, what you do first is rank the sentences based on some criteria. Okay, typically there are some metrics. I mean, not metrics. So there are some what did you say? Based on which the sentences are uh, sorted. Okay, salience and I forgot about the terms. I mean, nobody does extractive summarization these days. But extractive summarization is easy. You first rank the sentences, and then you pick up the top few sentences, and you say that that is your summary. So in that case, you are not generating anything new. Okay, you are only picking up the important sentences from the text itself and put them together as a summary. Okay, so this is very easy. But abstractive summarization is like human summarization. So if I give you a document and I ask you to summarize, so what you will do is you will read the document and then you will come up with your own summary. You will have your own understanding and you will write it up your own summary. Okay, so abstractive summarization is like that. So it involves natural language generation. So that is why it is difficult. In fact, I have not said that any kind of generation task is difficult. Okay, because if you think of natural language generation, or if you think of like generating music, or even generating a picture, okay, like computer vision, in typically you are dealing with giving an image or giving a video, you do some analysis, okay. But if I give you a description and then if I ask you to produce, I mean, build a system that can produce a picture which looks almost like real, okay, so it is very difficult to develop such systems, okay. And if there is any element of generation involved in your system, be it question answering or summarization or even machine translation, because you are essentially producing some natural language content, so it involves some amount of natural language generation, okay. But nonetheless, abstractive summarization is much more difficult than extractive summarization. Then knowledge extraction is so given, I mean, so the purpose of knowledge extraction is basically given text, given a corpus, you'll have to extract knowledge and put those knowledge into into a knowledge base. Okay, so how we as humans gather our knowledge? Just by reading and listening to lectures. Also, we gather a lot of knowledge by looking into things, by hearing, and by touching. I mean, in fact, we gather knowledge by our five senses. Okay, by say for example, a blind person gets a lot of knowledge about shape and texture, about things. Okay, but forget about the other modalities. Think of just the linguistic input. So, a person either gets some knowledge by reading something or listening to something, lectures or something, whatever. Okay, so that is the task. Now, typically in knowledge, I mean, knowledge is typically represented in the computer world as a triplet. So it's a relation between entity one and entity two. Okay. So typically, I mean, we do not know. I mean, cognitive science does not tell us how our brain, how the human brain stores the knowledge. But in the computer science world, it is a widely accepted fact to represent knowledge in form of a triplet. Okay, so it is considered to be a relation between a pair of entities. Okay, so that's basically the task. Now, you might ask why it is, I mean, what's the relevance? So think of it like, say, for example, I have the newspaper of all India newspapers from, I mean, no, maybe published from all the cities, metro cities from India in all the different languages for last 50 years. Okay. And if I have a sophisticated information or like a knowledge extraction system, okay, and convert all the information into knowledge. Okay, in fact, it is said that information. I mean, it is said that data is coarse-grained, information is much more fine-grained than data. Then knowledge is much more fine-grained than information. Okay, so if you can extract knowledge, if you can convert your information into knowledge, and then if you put it in your knowledge base, and then if you can write the proper SparkQL, then you can extract all those knowledge in fraction of seconds. Okay, that's the utility. Instead of processing all these billions of documents in real time, you can just fire a query in your knowledge base and you can get the answer. Okay. Now, how this is done? Take for example, John was born in Liverpool to Julian Lennon. You will have to extract knowledge from this particular sentence. Okay. Now, it goes through a series of NLP applications. First of all, we do, I think, yeah, I think these are the tasks. So POS tagging, first every word is assigned the POS tag. So these are the POS tags. Then dependency parsing. So the relations are not shown, but these arcs, they are the relations. Okay. Then we have to do NER, like this John is a proper noun. I think it's the previous slide. This is a person. This pool is the location. Julia is a person, and Lennon is another person. So you'll also have to do like name entity recognition. Then you might also need to do co-reference resolution, because in the previous sentence, maybe this John might be referred to as Lennon, as John Lennon. Okay. Maybe it was referred to as he. So in that particular case, so you will have to link he to Lennon in the previous sentence, or maybe in the previous before that. Then Liverpool has the nickname the pool. In fact, there are many cities in the world by the same name. In fact, in the US, there are 4 cities by the name Liverpool. In fact, in the UK itself, there are multiple cities by the name Liverpool. Okay, so you'll also have to do entity resolution and linking and so on. Similarly, for Alfred Nellon and Julian Nellon, you'll also have to link them. Basically, you'll have to do entity resolution and then link them with the proper entities. Then once you can do this, then you can extract these 4 pieces of knowledge, or 4 triplets. Okay, that Liverpool is the birthplace of John Lennon. Alfred Lennon is the child. I mean, John Lennon is the child of Alfred Lennon. John Lennon is the child of Julian Lennon. Okay. And in fact, you will notice that I have added here another 2 edges, which is the relation spouse. Okay. In fact, there is no mention in this particular sentence that Julia Lennon and Alfred Lennon are spouse of each other. Okay. But this is called to be the task of graph completion task. Okay. So given a knowledge graph, or given a graph in general. Okay. So you'll have to establish another, I mean, additional links, or basically kind of like inducing additional knowledge from that graph. Okay. Now, once you do this, once you extract such kind of information from all the sentences and put them together, then this graph will look like a large knowledge graph. Okay. Event extraction. The task of event extraction is to basically detect the appearance of an event in the text, and then you'll have to also extract the relevant details about the event. Okay. Now, the task includes identifying the event triggers and then extracting additional information about the event participants and their relations. So typically, the event extraction task is said to be identifying the 4 components of an event. So event mention, it is typically a phrase or a sentence that describes the event. And then event trigger is typically the verb or a noun phrase. Mostly it is a verb, but sometimes a noun phrase can also be an event trigger. Okay, so that expresses or triggers the event. And event argument are the main attributes of the events describing the event state change, like who or what or when or where or how, answering these questions about the event. Okay, and then you also have to assign argument roles to the event arguments. Okay, so take this example like In Baghdad, a cameraman died when an American tank fired on the Palestinian hotel. So here it talks about two events, died and fired. Okay, so this is one event trigger, and this one is another event trigger. Okay, and this entire mention is the event mention. In Baghdad, the cameraman died. Okay, this one is the first event. An American tank fired on the Palestinian hotel. This is the second event. Okay, and these are the event arguments like Baghdad, cameraman. So these are the arguments for the first event. Also, the American tank. No, died is linked. Oh, well, I mean, the first event is in Baghdad, the cameraman died. Okay. And the second one is, I mean, I forget about this one. I'm telling about this later. Okay. So this is causal-related relation. And then these are the roles, like Baghdad is the place, cameraman is the victim, and so on. And for the second one, the American tank fired. Okay. And it was, the target was Palestine hotel and so on. Then there is another task which is called the causality relation extraction of events. Okay, so you will have to basically decide the cause-effect relationship among events. If you have multiple events and then you can establish the causal relation between them, then you can have a complete event understanding from the logs. Okay, so take this example. After studying hard for the exam, Shara achieved the highest score in her class. So studying hard for the exam is the cause which led to the result Sarah achieved the highest score. Here, Sarah has not been mentioned in among the event mentioned because it could have been any person. Okay, that is why it has been not been put in hold. So in general, if you consider the event achieved the highest score is the event. Now, so this one green one denotes the cause and the yellow one denotes the effect. So it could be either explicit. So I mean, if you look at this particular sentence from the dependency tree itself, you will get that this thing is the subject, this thing is the object of the what caused. So you directly get the causal relationship. So it is explicit. It can also be implicit if the relationship is not clear, but it can be inferred in some ways from the context. Okay. So look at this long sentence. In fact, these are two different sentences. So here it says that this is the cause, and you'll have to discover that this is the cause of the this event is the cause, and this event is the effect. Okay. It can also be chained. Like you have this long, very long sentence. First, you identify just like the previous one. It has two different events. Okay. So this event is leading to this. Again, this event is leading to this. So there is a chain relationship, chain of causal relationship among the events. Okay. Similarly, there are it could be like one cause many effects. In this particular case, this is the event that is causing multiple effects or consequences. Okay, or it could be many to one relationship between the cause and the effect. So here there are multiple causes that lead to this particular event. Okay, why this is useful? It is useful in multiple domains. In fact, in biomedical domains, I had one PhD student who is now a lecturer at NIT Jamshedpur. So he did event extraction in biomedical domain. Then, I mean, you can also apply it in business domain for many different tasks. Similarly, in legal domain or sociology domain, there are many applications of event extraction and causality extraction. Maybe I will briefly talk about this and then try to end. So math word problems are basically solving those arithmetic problems that you have in typically in primary levels, like Harry has 13 apples, John has 5 apples. He gives 3 apples to Harry. How many apples does Harry have now? So these are apparently very, very simple problems that even class 1, class 2, class 3 level students can solve. But I'm talking about I had a student who used to work in math word problems. And I'm talking about the state of the art like 3-4 years ago, 2021. Even then, we did not have very sophisticated system which could do even such simple uh, arithmetic problems, deal with such arithmetic problems. Okay, even simple addition, subtraction, multiplication, division, and percentage. Okay, why? Because this is a problem that requires understanding a lot of uh, world knowledge. Say, for example, the system has to have this kind of world knowledge that if John gives Harry 5 apples, John basically loses position of 3 apples. Okay, and Harry gains position of 3 apples. Let's say it was like Harry has 200 rupees, John has 300 rupees, John Gibbs carry 50 rupees or something like that. So the computer has to have this kind of knowledge that if I buy something, I lose some money. Okay, if I give something, I lose some money. If I get something or somebody gives me some money, I gain something. This kind of knowledge, real knowledge. It requires a lot of real knowledge like that to solve such problems. I'm not going to say examples, and okay, maybe I will end with this and some domain applications. So context, I have a PhD student who is focusing on this. So it is like called contextual recommendation system. So think of this particular case. I'll just end with the example. Just have a look at this very long query. You don't have to read the entire query. But the thing is, if you put this long query, I hope you have understood what my query is. But if you put this entire long query in a Google or any other Bing or Yahoo or whatever is your search engine, it does not even understand that I'm basically, my basic requirement is I'm looking for hotels. I'm looking for hotel recommendation. Okay. In fact, I searched this last, I think, 5-6 months ago, maybe 1 year max. And that time I did not, in the entire first page, there was not a single page result which was about hotel recommendation. Okay. So that is the problem. So because every search engine expects that your query is very short, it has typically 2 to 3 keywords, maybe maximum 5-6 words, not much more than that. It does not expect any natural query. Okay, natural language like query, like you say, like you write. That not that kind of query. It considered the query just as a bunch of keywords, not any sequence. Okay. So search engines do not even understand that it is about hotel search or hotel recommendation. Okay, but if you are doing contextual recommendation, so the purpose of contextual recommendation is basically to understand the user context. Okay, in the US or in Europe, there they have this idea of working lunch. Okay, so because they're the professors or the senior people in companies, they are very busy. They do not give much time. I mean, even if they're not being very busy, they are very punctual and they don't want to give much time. Okay, even if they invite you, what they will do is uh, say for example they will have a meeting with you. Say for example he has invited you for 1 day. Okay, so what he or she will do is he will invite you to a lunch. Okay, so that he can, I mean, he's basically offering a lunch as well as he's having the meeting over the lunch. Okay, so it's like making use of the time to, I mean, he's not having, I mean, he does not have to spare 2 separate times for 2 different purposes, having lunch, I mean, offering lunch and having the meeting. Okay, but this for this kind of meeting, not every kind of restaurants or hotel is suitable. Okay, so you need a quiet place where you can typically have such kind of meetings. So there you will have to understand your requirement. So if I had a system which can do this, so my basic requirement is to basically book a hotel in Kolkata. That's my basic query. So I mean, if simply if I wanted to put it in a Google search, I will have to put it like book hotel in Kolkata. These 4 keywords maybe. Okay. Then I have a lot of context. Like I'm going to Kolkata for medical tourism. I'm looking to a hotel which is close to XYZ hospital. It must have wheelchair access, lift facility, doctor on call, and then it should not have, uh, like, it should not be very close to main roads. It should not be noisy. It should not be pricey. These are my requirements. Okay, so it should understand both my positive requirements as well as my negative requirements, which I'm not liking or not do not want, and which are the exact things that I want. If it can understand all my requirements, all my context, then it is very easy to recommend me proper hotels, because there are many sites like in TripAdvisor where you have a lot of reviews about the hotels or the restaurants or the other things. By analyzing those, it is very easy to recommend you such contextual recommendation. Okay, and maybe I will just end with this domain example. So just like any task, NLP is also domain specific. So if you build a NLP system for, say for example, education domain, say for example, only for computer science, So we built a system which can very effectively translate computer science text. Okay. Now that machine translation system will not work for other domains, like for mechanical engineering, or for even for history, or for even for physics. Okay. So you need domain specific system. So I have a PhD student who is a very senior student. So he's finishing his PhD in financial, but he's entirely focusing on financial natural language processing. So whatever task he's doing, he's only dealing with financial text like the company annual reports and different things, but they are all about financial things. Okay, but depending on the domain, you might have different tasks, altogether different tasks. Okay, so that's about it. I think I have taken a lot of time. I'm sorry about that, but if you have any queries, first of all, thank you for your attention. If you have listened, which I have, which I hope, and then if you have any further questions, I'll be happy to answer. Over to you, Mohidal.
Thank you so much, sir. Uh, Thank you, sir, for your valuable talk and on the broad perspective of natural language processing that you gave us today. And I hope all the participants and dignitaries present here have learned the core part of the NLP task and different phases of NLP processing. And since we have Dr. Sudhir Kumar Noshkar sir with us, I would request all the participants to come forward with their questions. Now you can unmute yourself and can ask questions to sir, or you can write or drop questions in the comment box in YouTube and Google Meet chat box. Anyone have any question can ask sir.
Well, if there are no
What?
question, yeah. Is there
Yes,
any?
sir. I think there is no question from the
Okay, okay.
from participants since you have described it very clearly, and so I think there is no question.
Anyways, so I think
So
yeah. I mean, I
yes, sir.
shared my Gmail ID, but or you can also search me in the web. So if you have any questions, you can ask me in mail. I'll be happy to answer.
Yeah, of course, sir. And once again, thank you, sir, for spreading your valuable knowledge with us. And sir, a certificate for you as a short token of appreciation from our side on behalf of Global Institute of Technology for spending your valuable time with us. So you can visualize your certificate, sir.
I cannot, but it's okay. You can send it.
Okay,
Yes.
okay, sir.
Okay. I
Okay, sir.
thank the organizer for giving me this opportunity to interact with the participants. Thank you very much.
Yes, sir.
Thank you very much, sir. Thank
Thank you,
you.
Mohit, for
Thank you,
inviting
sir.
me.
Thank you. See you again.
Okay, bye. Yeah, I can see the certificate. Thank you.
Oh, yes, sir.
Okay, I'm dropping. Thank you and bye, everyone.
Okay, sir.
Okay.